Hello everyone, welcome back. Yeah, today we're going to be discuss about the Kafka, what exactly Kafka is and how Kafka work internally. All of these things will going to be covered in this video. Let's talk about the what is exactly mean by the Kafka. Okay, so Kafka is the distributed event streaming platform used for the building real-time data pipeline and streaming the application. आपको ये समझ में नहीं आया होगा डेफिनेशन बट ये डेफिनेशन आपको याद करना होगा सो दैट आप उसको एक्सप्लेन कर सके तो मैं एक बार बोल रहा हूँ काफका इज अ डिस्ट्रीब्यूटेड इवेंट स्ट्रीमिंग प्लेटफॉर्म यूज फॉर द बिल्डिंग रियल टाइम डेटा पाइपलाइन एंड स्ट्रीमिंग एप्लीकेशन तो स्ट्रीमिंग एप्लीकेशन कौन से होते हैं जैसे कि नेटफ्लिक्स नेटफ्लिक्स एक वीडियो प्लेटफॉर्म है वो भी एक स्ट्रीमिंग एप्लीकेशन है एग्जाम्पल दो तो आपका जो भी यूट्यूब है यूट्यूब ऑल्सो द स्ट्रीमिंग प्लेटफॉर्म और एक व्हीकल्स में जो ऑटो ऑटो व्हीकल होती है जो ऑटो ड्राइविंग व्हीकल होती है वो भी क्योंकि वो रियल टाइम डेटा कैप्चर करती है यानी एक्शंस करती है प्रिडिक्टिव एनालिसिस करती है तो उस केस में अपन काफका यूज करते हैं तो काफका कहाँ कौन सी कंपनी यूज करती है सो Kafka use basically LinkedIn, Microsoft, even Netflix. Top MNCs also use the Kafka, and nowadays tech insurance company also use the Kafka. So Kafka is too important, and some functional some mm, scenario where you have to use Kafka and it too easy to use over there and you will get the output very high with low latency. Okay, so let's why Kafka क्यों यूज करना चाहिए सो फर्स्ट पॉइंट इज हाई थ्रूपुट देखो कोई भी थ्रूपुट हाई दे रहा है इसीलिए उसको यूज करना चाहिए स्केलेबल एंड डिस्ट्रीब्यूटेड सिस्टम okay so it's scalable and it's used in distributed system okay fault tolerance and real time data processing you don't have to wait too much it's real time data processing durability and reliability it's reliability and decoupled system so you don't have to do too much it's already in your place you have to just configure with your system and it's ready to go you don't have to pull the api every time okay so that's why you have to use the kafka or where we will going to be talk where we don't have to use the kafka and where you have to use the kafka we'll definitely see that as well before we start with the architecture we're going to discuss the traditional way what was the problem why kafka come into the picture okay so problem happening with the past like in the traditional communication or traditional way what was the problem that's why we found the kafka and we use the kafka to avoid that problems let's see somewhere you are tightly coupled system like you have the service a to tightly coupled with the service b basically so that if your service b is down you will get the service a also down means that you are tightly coupled with the service so that to to avoid this problem we use the kafka next problem what happening the real traditional communication is if consumer is down producer also fails let's see if you wanted to send the email to xyz user send the send the email to xyz user so you have the send service which send other service to tell them ki send the email to xyz person okay that case you are if your xyz person is down that time what happens? So your entire service fails. Okay, it means that you will not get the email. So next problem was occurred, no buffer for the high volume of data. And then next problem was the hard to scale. You aren't able to scale too much because you are tightly coupled. Each and every service are interconnected, and they are calling each other and waiting for to other service to complete give the response, so that it very hard to scale. Okay, so hard to scale. Next problem was the no real time data processing. Sometime we have big data, we do that data in background. We not get real time data, so that we face no real time data processing. Okay, so you get the thing what was the problem and why we are using the Kafka and why we need the Kafka. Okay, so this was the problem which where we was facing for the traditional communication. Now we are we have the Kafka and it's very easy to solve this problem. Let's talk about the real world example with the Kafka. Okay, let's let me think what is the real world example. I will select the e-commerce ordering system basically. Okay, I will just give the flow, y- only flow. Okay, so yeah, let's talk about the e-commerce ordering flow. Let's see, we have the order service which let me scroll up little bit. Which let's see, we have the order service which send the service which serve the order, um, and once the order service have we have the different call the different server like inventory server, payment service, email service, and um, real time data communication service. Okay, so in traditional way how does it happen? It's happen like this. You directly communicate with the service like the inventory service. This will be the inventory service because we have to tell this inventory we have to remove because it's sold out. Inventory service. Then we also have one more service which call as the payment service, means we payment is received or not. Payment service. Then we also have the email service. We have to send the notification to email service. Email service, we have to send notification to user as well as the owner of the shopkeeper, so that they will get notification via the email or any other channel like phone, WhatsApp, any channel, so that this was the service. And one more service was the real time location service, where we get the real time of the location service basically. Okay, so with this service you will get the location. This is the traditional way to do all of the stuffs. Nowadays it's very complicated. Let's see, your order is done, you are processing the inventory as well, payment as well, email as well, and location as well. We will wait until the this whole service responds us whether it is completed or not. Okay, so then we'll respond to the user, so that if this will be the too much wait and it will take too much time. Okay, so in the traditional way. Okay, if suppose we not care about these services, let's see, the we only send the request to do stuffs do the works as per service. In that case, sometime inventory is down, inventory service is down, that time we will get lost the data, so that we were going to be lost data as well. So that in that case we are not going to be follow the consistency data, so that may overhead or facing problem, because inventory service is down and this will not update the data. So nowadays we have the proper solution and good solution to all of these things. Okay, so we'll discuss on that, what exactly the solution is. Let me select this and little bit move over here. Okay, so now we have the Kafka in the place. Let me clear these things, we don't need these things right now because we have the Kafka. Okay, we have the Kafka over here. Why I make this Kafka little bit, because I wanted to explain the internal working as well Kafka, how it works internally, so that I am I have created the Kafka too big. Okay, now our service order service send event to the Kafka. Okay, so that event we have the Kafka, and based on that our consumer will consume the event. Okay, now let's see, this is the Kafka. Okay, Kafka, and this is the Kafka, and we have inside the Kafka we have the Kafka cluster, which which is called the brokers as well. Okay, so in this area we have the Kafka cluster. Okay, this is the Kafka cluster. Okay, and in this Kafka cluster, we have the different broker, like broker 1, broker 2, and broker 3. There might be a lot of broker. And broker name broker 1, 2, 3. We have the broker 1, 3, 2, 3. Okay, 1, 2, and we have the 3 third broker as well. And each broker have, I will I will define this broker architecture outside because we don't have too much space over here. Let's see. I am copying this broker to here, and I will explain this broker internal architecture in this area. Let's see. We have the inside the each broker we have the topic. Okay, what topic exactly mean? I will explain you later on. But you remember the things. This is the topic A. Okay, and topic A contains the different partitions. Why we need different partition, I will let you know. We have the partition 1, partition 2, and partition 3. Okay, let's see, this is the little bit wrong, like messy diagram, but you can understand. We have the partition 1, partition 0. It start from 0 actually. Partition 1, and then we have the partition 2. Okay, we also have the partition 2. Okay, so we have the three partition in this topic, and here we also have the topic, topic A. Same over here as well. We have the topic A, so that every broker have the topic A. So what mean by the why we created the different broker? It I will tell you, let you know why we created the broker different. Okay, and each topic have the different partition. You will confuse why we created the different partition in same topic. We have the same, we have the topic, and why we need the partition. But we need the partition because in one because in first broker, our master partition will be the 0. In second topic, master partition will be the 1. And in topic third broker, and our master partition will be the second. Why is this so? It's writing. Let's see, if you receive the any uh, event in the topic third, okay, so it will update the insert the partition, insert the event in the partition 2, not the partition 1. But once the partition 1 2 is inserted, it will automatically sync, uh, seeing the and the copy the event in other partition as well. We have the round robin algorithm, so it automatically sync others data into the other topics and other broker as well. Means other broker, like over here, topic A, topic B, and topic C, it will automatically sync. So that if suppose um, if suppose your order service is sending too much data, like producing too much event, so that if you are only inserting the event in only one broker, means that your system might be down. So that case, it will automatically check other system, is it working or not, then push into the other broker. Like that, it handle massive event producer as well. Like, it does not matter how much producer send the events, it will automatically consume, because we have the scalable architecture in the Kafka cluster. Okay, so once the cluster is done, okay, so we have the consumer automatically consume the each topic whichever they want. So it will consume the topics, and each consumer have the each its itself offset. What does mean by offset? Offset is the key point where key point where they are consume the events. Let's see, my inventory consume event from the partition 06, it will keep the offset of the 6. So this is how it works. For each consumer have the its own offset basically. Okay, this is the architecture of the Kafka, and this is the pretty much good for the Kafka. Okay, I think you are understanding what I exactly mean to say. Okay, so this is how the Kafka work internally, and some terminology of the Kafka. In the older Kafka, we need the external zookeeper, but nowadays we have the graph inbuilt with the Kafka, so we don't now need to run the zookeeper. It was the cluster coordination and metadata it's handle. So it was the monitoring, we can do the some configuration in using the zookeeper. So it's handle the some, it's run in the algorithm as well zookeeper. But nowadays we have the kraft, so we don't need extra extra s- external k zookeeper for it. But you you have to know about what exactly zookeepers mean. So it's simply zookeepers mean it's a cluster coordinate and handles the metadata. It use for the it use for the it use for the it use for the configuration and coordination. Okay, so this is now it's replaced by the kraft. It inbuilt meta mode, so we don't need the zookeeper. It's built on the raft consensus, so you don't need it. Okay, so next, some terminology we will going to be discuss. So broker, as we discuss the broker, what does mean by broker? Broker is the Kafka server that store the data and handle the request. Basically, it's called the broker. And what mean by the Kafka cluster? Branch of brokers come in together. That's called the Kafka cluster, which each broker run on different port basically. Next thing is topic, which is most important. Topic is a logical channel. Topic is a logical channel to which the produce the public messenger. Okay, okay. So topic. What does mean by topic? Topic is the legal logical channel to which producer publish message. Topic is most important. So if interviewer ask you, just tell them a logical channel to which produce the public messages. So this is the topic contains the partition. So that next our thing is partition. What exactly mean by partition? Okay, so partition is a topic is split into the multiple partition. Each partition is ordered and immutable. Once the topic is created, it's immutable, you can't edit it. And also, once the topic is pushed into the partition, sorry, each partition have the sequence like 1 2 3. It start from 0 1 2 3, just like a array, so it consider. And also in topic partition have the sequence like partition 0 1 2 3, as I written over here. So that's called the its order and immutable. Okay, next thing is the offset. As I said earlier, offset. What exactly mean the offset? Offset is the unique number assigned to each message within the partition. Okay, so I already tell you what exactly partition, how it look like. So let me scale little bit. So we have the partition like this. This is the one partition. I am drawing the its structure. It's contain the different messages. This is message 1. Okay, so this contain the message 1, message 2, message 3, message 4, message 5, message 6. It start from the zeroth message. It contain the sequence. Okay, so offset mean if you are any consumer, it's reach like you over here, so third position. That means the offset of this uh, consumer is 3, so that's called the offset, nothing else. Okay, so that's the thing. And one more thing you have to remember, each message is immutable. Once it is created, you can't edit it, because you don't know how much consumer reading that, because there are multiple consumer are capturing that, so that once it is created it immutable. Okay, so next thing we'll going to be discuss is the replication. What does mean by replication? Replica. So replica is just the partition of and the replicated across the multiple broker for the reliability. Let's see, we have this t- Kafka broker over here. So we are just replicating that Kafka broker with this broker number 2, so that it's called the replication. As it is server, we are replicating with the other, just changing the no port and some configuration. Okay, so next thing is a zookeeper. Zookeeper, as we already discussed, the what does mean by the zookeeper. Okay, so let me write zookeeper. Okay, so Zookeeper used for the broker coordination and metadata management. In new version, it replaced by the Kraft. Now, if you are using the Kafka old version, you must need the Zookeeper for the managing the coordinating and the metadata management. Like what does metadata? Metadata means configuration. Let's see your some um, log and profile management basically. Then Kraft. What then mean by Kraft? Okay, so in newer version, it use in newer version Kafka Raft metadata mode. It's a Kafka wrapped metadata mode. No use for the zookeeper. No need of the zookeeper if you are new version and build on the wrapped consequence. So you don't need the zookeeper in this new version. Okay, so this is the terminology which lot of things use in the interview as well. So okay, so this is the thing, and I think this is the pretty much good for the Kafka. I think you understand the oral Kafka, and thank you for watching.